Hi there. Regents Review Session 3 is trigonometry and constructions. Remember, with trigonometry, we're talking about sine, cosine, and tangent. Please remember that this is not given to you on your formula sheet, so you want to make sure to remember your comparisons. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The other thing that you want to remember and you want to make sure to take note of is check your calculator to make sure that it's in the right mode. So you want to make sure that your calculator is in degree mode. And remember to do that. You hit sine of 30, and sine of 30 should be what? That's right, 0.5. If your calculator is not in this mode, you need to change that by going to your settings on your calculator and go to document settings. I think it's 5, and then you choose 2, and it's the second box down, which is the degree mode. So take a moment to write this down in your vocab notebook. Draw this triangle. Remember, if this is your angle measure, opposite is across the shape. The hypotenuse never changes. It's always across from the right angle. And the adjacent is the one that's closest to and connected to the angle, except it's not the hypotenuse. So if we look right here, just a couple of examples that you probably want to write down. If I'm looking for the tangent of z, the tangent of z, z is here, tangent is opposite over adjacent. So the opposite is 21. The adjacent is 28. You might want to mark those down in your notes. Physically write opposite here, adjacent here. 21 over 28 simplifies to 3/4. Again, a review of sine. Remember, if we're looking at this angle measure of C, C is right here. Sine is opposite over hypotenuse. Opposite is 28. Again, I would write the opposite next to this number right here. The hypotenuse is always across from the right angle. That's 35. 28 over 35 simplifies to 4/5. And again, a review of cosine. Cosine of A. So A is right here. Cosine is the adjacent over the hypotenuse. The adjacent is connected to, but not the hypotenuse. So the adjacent is 30. The hypotenuse is 34. 30 over 34 simplifies to 15 over 17. Please understand how to get those comparisons. Remember, tangent just means compare two things. Sine, compare two things. Cosine, compare two things. What you compare is what changes based on the word. Now, if we have examples that we're actually looking for a specific number, for example, right here, we're looking for this side. We have this angle, and if you're marking, then across would be the opposite. We have nothing about the opposite. We know the adjacent is x, and we know the hypotenuse is 6. Adjacent and hypotenuse is cosine. Cosine of 73 equals the adjacent over the hypotenuse. And then when we do this, we cross multiply. So we actually put this over 1, and you cross multiply. When you cross multiply, 1 times x is x. Here, you're going to do 6 times the cosine of 73, and in your calculator, you should get 1.8. So this value is 1.8. The other process that you could have is if you have the angle measure, this time you have the opposite, and you have the hypotenuse, so you're comparing the sine. So the sine of the angle measure, we know the angle measure is 51. The opposite is 14. The hypotenuse is x. My apologies for the dogs barking in the background. So we have the sine of 51, the opposite is 14, the hypotenuse is x. When you cross multiply, again, we can put this over 1. We can put it over 1 because we have the angle measure. When we put this over 1, when you cross multiply, again, I always start with the variable just because in my brain that's how it works. So I always do x first. So x times the sine of 51 equals 1 times 14, which is 14. Then you need to divide by that sine of 51, because eventually what happens is you want that and that to cancel out. So you want those two things to cancel out. That will give you x equals 18. So in your calculator, you're going to plug in 14 divided by sine of 51. The last type that we've done is when you have the angle is missing. My dogs apparently want to be in this video. So this time we do not have the angle measure. So when you don't have the angle measure, again, you want to find out what you're comparing. In this case, we're comparing opposite and adjacent, which is tangent. When you don't have the angle measure, you need to, when you set this up, you have something that looks very similar to what we had before. We have the tangent. Oops, sorry, I just slipped out of the page here. But what we have is we have the tangent but we don't know the angle measure. And when we don't know the angle measure, that's when you need to plug into your calculator what we call the inverse button. And so when you plug into the calculator, you hit inverse tangent, you divide 27 divided by 38, and you get 35 degrees. Please pay attention to what the problem is supposed to be, is asking you to round to. That's going to be your biggest issue. This is the nearest degree. This is obviously rounded to the 10th. This is rounded to the 10th. So please pay attention to that. The next set of reviews is construction. Really, really important that you have the construction of steps in front of you. Sorry, I was a little tongue-tied right there. Perpendicular bisector. When all else fails, draw the fish. Please remember, you open up your compass from one side to the other. This one only went halfway. You can go a little bit over halfway. Create your fish, and what you have is a perpendicular bisector, a 90-degree angle, and then this piece and this piece will end up being equal. So what it does is it creates a 90-degree angle, and it creates this side equal to this side. We're all very good at the fish, I believe. The angle bisector, when you're given an angle, you want to put your compass point on the vertex, and you want to make the reference arc. That's what they did right here. They made a little reference arc. You measure the reference arc, and then you make another little marking out here, and you connect the vertex to that intersection. What that does is it creates two equal angles right here and right here. The equilateral triangle, usually you start out with a segment. In this case, my straight line is not working very well, but you measure the segment, and then a lot of us have drawn just arcs that kind of come all the way down like this. You can just draw pieces of that. Totally up to you how you do that. But equilateral triangle, all the sides are the same. So really it's just doing kind of like half a fish. We could have an equilateral triangle over here if we had the length of the side on the bottom. So you want to make sure to open up your compass, the length of the base, and then you can kind of just come up and you can actually connect and then flip your compass over and do the same thing, and that's how they get that other arc. The equilateral triangle inscribed inside of a circle. In this particular case, these two constructions are very similar. You measure the radius, you make a little point where that radius intersects. So you're measuring right from here to here, and then you take your compass point and you put it on the same spot, and you make 6 little arcs. The only difference between these two constructions, with an equilateral triangle, you're connecting every other arc, whereas a hexagon, which means 6 sides, hex 6, then you want to make sure to connect all of the arcs. And then the last two types of constructions that we have seen are perpendicular lines that are on a line, through a point on a line and through a point that's not on a line. So either way, what you need to do is you put your compass point on the point that you're given. So in this case, for both cases, it's the point P. And what you need to do is make a reference segment. So in this case, you open up your compass however large you want it and make a reference segment. And this one did not show the whole thing, but really what you're doing is you're finding the perpendicular bisector between this point and this point. So really you're taking and you're making a fish all the way through both of those points and you're connecting. The same thing over here. The only difference is you're starting with your compass point on the point that's not on the line. You're opening it up so you make this reference arc, and then you do the perpendicular bisector of that. My lines are not very straight, but at least you can see where I'm pointing at. Okay, so in this particular case, you're taking your compass and you're putting it on this arc, and then you're making the perpendicular bisector. Notice there's a fish here. Notice there's a fish here. In all actuality, there's a fish here. There's a fish here. So really, when all else fails, draw your fish, which is the perpendicular bisector. Have a great day.